Hello everyone, this is Dundun92, and this is going to be a brief continuation of the previous mission, or not really a continuation, as I didn't actually start the mission. But the goal of the previous mission was to find a way to get directly from basically the mission setup was this: a realistic mode XR-2 in terms of fuel economy and all that, with the goal being to set up a transfer to the moon from the ISS without doing a plane change, so an off-plane transfer. The way I'm going to do that is go to the ISS and then set up a transfer to the moon. Turn on a maneuver node. And just set a high prograde velocity. I'm just doing this to get a good indication of the phase angle. Not really phase angle, but the angle needed to be in front of the moon. We need to be in front of the moon to get a good Hammond transfer.
We have a location. Standby, Steve.
So we want to time our arrival date with us arriving at the plane of the... And I see what's happening.
Good copy. And Eileen, if you guys have a chance to queue up some centerline camera views as well, we'd certainly like to see that too.
I see what it is doing right now. So I just have to find a Hammond transfer. I'm going to do a quick Googling of the Hammond transfer angle for the moon. For some reason I can't think of it off the top of my head right now, the actual technical name for this, but... Again, this is just to find an approximate transfer angle.
We have a location. Standby, Steve.
Really, the transfer time to the moon is about 3 days, so we just need to figure out how many degrees the moon moves in 3 days on its orbit. Well, actually, it's probably a bit more than 3 days, but...
Discovery Houston, Wendy. Transfer? We're ready.
The orbital period of the moon is 27 days. And this is just 3 days, so that would be 3/27ths of that. So we travel about 3.6 degrees. Roughly travel about 3 to 4 degrees during the transfer between us and the moon into 3 days. So that means we pretty much need to find a date where the position of the moon coincides with the plane of the moon. So this line here, where the plane of the moon intersects with the ISS. It's a little bit behind to give us some time. But finding a good launch window like this is the important part. So right now, I would say that that's about probably a bit more than 3 degrees, but we'll have to do for now. Now we're going to switch to the XR-2 on the ground. That's the payload module, not the XR-2 itself. And the external cooling was not turned on. Okay. Let's run the scenario editor here. Edit it. No, I will not be able to do this. I'll have to restart the mission.
Welcome aboard, Commander. All systems nominal.
The first thing I'm going to do is turn on external cooling. Open up the fuel and locks hatch.
No external line pressure. Refueling system locks.
Once the hatches are opening, I'm going to load our payload base. Because as I mentioned in the previous mission, essentially we now spawn with 50% main fuel and no internal scram fuel. So in order to get full scram, and each tank is, one scram fuel tank is full internal, but one main fuel tank is only 25% of internal. So, and I only have 2 bay tanks, so you'll have to make a compromise. In this case, I'm taking 75% main fuel and full scram fuel. I can switch to scram fuel for a main fuel tank on the ISS. Anyway, let's open up the lock signs.
Scram fuel tanks.
Fuel everything
APU
maximum.
Main fuel tanks full. Crossfeed off. Crossfeed off.
Now that we have the external cooling set, we can actually now close the fuel and locks hatches.
Locks resupply systems.
And now we're going to switch to the ISS, because I think this time we're going to try docking to the ISS instead of Mir.
Commander. All systems nominal.
We're going to go to Transx and wait till the moment when the moment where, because essentially here's what we're trying to do here. We're going around the ISS's orbit. I don't know if the mask is visible. We're going around the ISS's orbit like this. We're trying to target the moon. But because the ISS's orbit is in a different plane than that of the moon, like the ISS is in a 53-degree inclination orbit, whereas the moon's in a 5-degree inclination orbit. So if we don't do our eject burn at the ascending or descending nodes, where the ISS and the moon's orbits would intersect, if you could, the planes of the orbit intersect, we're going to end up too far up or down, above or below the moon. So we're essentially just time warping until we reach a point. So you can see the current position of the moon here with the blue line. The gray line represents the line of the planes where the planes intersect. So all we're doing is waiting until we hit a point where the planes of the ISS are pretty well aligned with the planes of the moon. As I said, the moon is going to traverse about 3 degrees in the time period between, you know, to eject burn to the arrival of the moon. Right now I'm actually going to do a quick prograde velocity burn just to see.
Houston and Discovery Station on the Big Loop, we show ourselves complete with the robotics ops today.
You can see there from, but this is a perfect example of why you need to align the planes, because you can see here in this view, you can see how our orbit, this plane is nowhere near aligned. I said as the moon's. So let's switch our view here. Graph projection. Scale to view. Okay, here we go. Now from this view here, we can then align our maneuver with the see, that's way too fine. We need to align our maneuver with the line of planes at the moon. So, for example, right here. Now we will set the scale to view to the scale to view to all, and then set a projection to.
And Thomas, I'm ready on space to ground 2 for the transfer brief.
Actually, I'm not exactly sure where that option was. I think it was this option. Yeah, that was the option. So now that we set it to the plane of the ecliptic, now we can adjust the prograde velocity to try and get a closer encounter.
Station Houston, welcome aboard, Lisa and Stephanie. Nice to hear your voice.
Looks like the moon is moving through a lot more of an angle than I thought it would be during this burn, or during our translunar injection.
And Steve, we have a
I'm
location
looking
to
at
put
this.
that grab sample container. Once you've filled it, you can call us back when you're ready.
It appears that
We
we'll
have a
have to
location
try this
standby.
again, but with a different timing. Now we have a much better idea of how much lead angle we're going to need.
Welcome aboard, Commander. All systems nominal.
So now we need to do the same process that we did here. Payload. No, I don't want to turn on the APU. Great. I also do realistic APU burn, so it burns a lot faster than normal, so that is definitely something that I will be refueling at every spot I can. But in any case, we should have more than enough APU to get to the ISS, so we don't have to worry about that little that we use.
Using external
External
O2.
cooling, we need to make sure that is on,
copy.
however.
1014 is in
External
node
cooling
104 golf.
online.
So we can now switch to the ISS,
Welcome aboard, Commander.
and then
All
go to
systems
TransX.
nominal.
Sounds good. And one little last thing. We're still working on activating the IMV valve. We've had some commanding issues on the ground, but we're working on it, so just so you know, it's not quite complete.
I'm going to set the moon as our target. Now we're going to try right here. Mission to see. Turn on the maneuver node. And we're going to add in the prograde velocity. Obviously right now the timing of that is way off. But that's, nope, I don't want to make that more sensitive. I need to make it less sensitive. I mean more sensitive, not less sensitive.
Okay, copy. Overnight, the machines will leave on the OCA router, KFX, RPOP, RPOP2, and WLES. And we'll have KFX running on RPOP and the KFX machine.
We need to align that with the plane. We need to typify orbit diapopsis with the orbital plane. And now let's see what we have here. Now we have a really natural, close approach. Just minimal course correction. All that we'd have to do at this point is adjust the maneuver date to get a really
Hey,
close
Jeff, we were
approach.
talking to Mark earlier on the Aruba leak check, and we gave him a go to proceed with
So let me go to the
SF4,
orbit
but
MFD
we're
now.
not sure if we got a return call.
The
or
target
if it went
as
through.
the
So we just wanted to confirm he got
moon.
that
Let's see.
communication.
Good frame. You just set the frame to... Fortunately, I don't actually think you can set yourself as the frame here.
Standby.
Right now I'm trying to figure out essentially how many degrees in front of our line of planes between us is the moon. I can get this down exactly in using, say, orbit MFD to exactly calculate the lead angle, to put it in simpler terms. Because right now I have no way of figuring out what that exact angle actually is.
ECLS confirms that the PBA's serial number 1010 has to come home. The reason is because it has expired its certified life, so it needs to come home so you can move it as per the transfer plan.
You can, not so helpful saying that you can't get the line of nodes relative to the target. It's the line of node relative to the eclipse. You know, when is the ecliptic or is the equator? Anyways, I guess regardless of whether we're able to consistently reproduce it, for now, we have a alignment that will work. So now we need to spawn in to our XR2. Now, set our target, and we're going to set ourselves up for ascent. So reverse MVD on the right side.
On SSC 5.
Align planes on the left side, and we'll set a target there to ISS. Now we need to time warp until we hit the ascending or descending nodes. I might need to look on the map and see what our ascent heading will be. Our target to ISS. You can see where they're going to be taking the southerly heading. So we're going to be taking the northerly ISS ascent heading, which I do not happen to know offhand right now, but I will look it up really quickly. I think it's like 53 degrees or something like that.
Discovery Station on the Big Loop, you have a go for OBSS grapple.
Launch azimuth, that's the better term for that. For the ISS, let's see. So it's 45 degrees launch azimuth from the ISS. So ascent time to orbit is about 8 minutes, and we want to essentially get into orbit just as we're crossing the plane of the ISS. Actually, how long does ascent to orbit take in the XR2? I don't know, I'll just guesstimate this and say at 300 seconds time to node. Actually, I'm going to do the ascent right now, actually. I think we're close enough to the node.
Using onboard O2.
onboard O2.
On.
Nav control surfaces on, and we're rolling.
100 knots. V1.
Steve, we've performed our side of the work. If you check that the MPV is full open, you can then
Gears
open the
are
hatch again per decal.
Warning. Gear deployed. Gear up and locked.
I'm gonna head to 045 while climbing. A steep angle of climb.
Mach 1.
We're supersonic. We're at 12 kilometers altitude. It's probably a good idea to begin our pitch over inverted.
Mate and demate the QD again and let us know what happens.
So one of our bay tanks is empty. Tank 2 is our main fuel tank, which is fine. Again, that's completely normal and intended because of our fuel tank arrangement. So we activate our scram engines at Mach 3.5. That's the speed at which we're going to do this. We open the scram doors at around Mach 3.
Mach 3.
We start up the scrams. Cut the main engines, and now we're coasting on scram acceleration alone.
Mach 4.
Now to keep the temperatures down, we're going to have to pitch up a little bit here. You can see our temperatures are climbing really rapidly, but we don't want to get the ascent rate too high.
Mach 5.
You see here we actually need to pitch up a bit more, keep our temperatures down. But as soon as the temperatures are brought down, we need to lower our nose. Our vertical speed is a bit too high right now.
Station for transfer standby.
Mach 7. Mach 8.
I'm going to use some help to trim here in order to bring our nose in a stable position.
Mach 9. Mach 10. Information. APU fuel 90%. Mach 11.
And unlike my previous scram ascents, this is a completely manually flown scram ascent. Without using the attitude hold autopilot, I thought it would be a nice challenge to try it.
Mach 12.
So yeah.
Discovery
Mach
Houston for
13.
Wendy on your question. We do not need the serial number and we'll get them when you get back.
Mach 14.
By the looks of it, we probably started our ascent a bit too early. It could have been that we started it too late. I don't know exactly which one right now.
Mach 15. Mach 16.
See, with the scram ascent with our XR2, it's a lot lighter than a stock XR2. Just because of the
Mach 17.
Station for transfer, stand by.
Actually, it's a lot lighter than stock because the oxygen levels I put down to the more realistic levels. The amount of oxygen being carried. Well, not realistic, but it carries a lot less, so it's overall a lot lighter. Plus, I removed the crew habitation module that default spawns in it. And the basic difference here is that we're going to be encountering our scram temperature limit well before we actually run out of scram fuel. But I have found that you can actually keep ascending on those almost at the edge of overheating scrams. Simply climb while...
Warning, scram temperature.
Right now we're going to begin to climb, because you can see we still have positive acceleration.
Scram
So,
temperature.
we're generating some thrust.
Warning, scram temperature. Warning, scram temperature.
And this is evident by the fact that our airspeed is pretty much remaining constant even though we're climbing.
Scram temperature.
If we just cut the scrams, that wouldn't be the case still.
Warning, scram temperature. Warning, scram temperature. Warning, scram temperature.
And Steve, we have a location
Warning,
to put
scram
that grab
temperature.
sample container. Once you've filled it, you can call us back
Warning,
when you're ready.
scram temperature. Warning, scram temperature. 21. Information. APU fuel 80%. Warning, scram temperature.
Even though it's throwing those scram temperature warnings at you,
Scram temperature.
nothing's actually going to happen, because the scram engines will throttle back
Warning,
to stop you from
scram
accelerating so
temperature.
quickly that you overheat the scrams. But the point being,
Warning,
you still
scram temperature.
generate some thrust. Like right now, the reason why the scrams aren't generating that much thrust is because of the... partly because of our climbing, but also
Warning,
partly because it's
scram
being artificially
22.
throttled down to, you know,
Warning,
And Jeff,
scram
that should take care
temperature.
of our KU band
Stop them from
4
overheating.
response, and we'll be able
Warning,
to mail
scram
sync
temperature.
and also we'll solve the problem with the OCA router.
Warning,
Thank you.
scram temperature.
now that we're getting higher up,
Rotation.
we're going to turn our RCS to
Warning,
rotation.
Scram temperature. Warning, scram temperature.
You can kind of see here,
Warning, scram
our time to
temperature.
apophis is not getting any further away.
Warning, scram temperature.
So we're just going to keep flying like this,
Warning,
essentially,
scram
until we can't
temperature.
get any more acceleration out of the scrams.
Warning, scram temperature. Warning, 20 scram
Turn
temperature.
to aerodynamic control surfaces to just pitch only.
Warning, scram temperature. Warning, scram temperature. Warning, scram temperature. Warning, scram temperature. Warning, scram temperature.
Those are our 86 kilometers. I don't think our scrams have
Warning,
any more
scram temperature.
useful time, really. Now we're going to activate our main engines.
We copy on air to ground 2, auto activation part 2 complete.
Mach
Oh
24.
yeah, climbing onto scrams is a trick I discovered when last trying to do this mission, and it actually works pretty well.
Mach 25.
So we're going to set ourselves to prograde.
Mach 26.
And right now we can open the radiators, which I actually should have done earlier, so I can save on DAP fuel. Anytime our temperatures are below 480 degrees
27
Celsius,
plus.
and the dynamic pressure, and hang on. So target to the ISS. ISS is 350, so we still have some burning to do. Okay, so we overshot a little bit, but that's okay,
APU offline.
because we're going to lose some of our altitude because of our apophis altitude just coasting here through the atmosphere. So actually this should end up working out just fine for us. We're going to get to the apoapsis time, which is in 900 seconds. Then let's do a quick prograde burn. It's not going to be very long, just enough.
Station Houston, space to ground 2 for John.
Alright. Now we need to do a rendezvous as soon as possible with the ISS. And for that I do a two-stage process, so right now I'm going to use sync orbit. Like right now, for example, as you can see right here, we are in front of the ISS by a considerable amount. So that will mean we'll have to slow down, which means we'll have to do a prograde burn. We'll wait until we arrive at the intersect burn to do this. Now we don't have an intersect point, which is great. So where are we in our orbit?
Discovery station on the big loop.
We're almost at the periapsis. Good. So we need to point retrograde and bring down our periapsis. Right now it's just our apoapsis. I mean, bring down our apoapsis, sorry, because our periapsis is just way too high. There we go. Now we should have a much more solid reference point. We're going to point ourselves back prograde. Actually, I'm going to try planning this using IMFD. Actually, no, but that's going to require a good estimate of the time to intercept, but that actually, I'm going to try using that IMFD itself. Go to the menu, the course, target, intercept. Set the target to the ISS. As you can see here right now, it's giving us a ridiculous amount of delta V because
Houston and Discovery station on the big loop. We're just stopping to try and turn on some lights here.
what does those prograde here and try and get a good intersect. I think 4 orbits is a reasonable time period to look for an intercept at.
That option we think is going to be the one that should cause you the least trouble.
There we go. Now we're going to set IMFD to this time to intercept. 23,000 seconds.
Okay, great. That helps a lot. We'll talk about it. We'll get back to you.
Joseph, start you now, honey. That's it.
Right now, IMFD is not giving us a very coherent solution, but I'm just gonna time warp us around until we get about, it's about 2 orbits away. Now what we're going to do is point us to the retrograde and do a little burn to lower our periaptus a bit so our encounter with the
Copy, we'll dial in on SSC 5.
our encounter with the ISS is a bit more certain, to put it simply. Because right now our orbital fluctuations are taking us in between having an intercept and not having an intercept. Let's bring the periaptus down a little bit. And also bring up the align planes and do a quick burn to like align our planes. That being finished, go back to sync orbit. As you can see here, our encounter is a little bit off, as in the time for our encounters, but that's fine. So right now we're arriving at there a bit earlier than it is. Let me just slow down our orbit just a little bit. Not slow down to orbit, but slow down our orbital period. I don't know why it's giving me this nonsensical solution that's requiring all this delta V. Let's move the time to eject further forward and see if that has any effect on this. Ah, there we go. Because you just set it to closer forward. So now we should be able to remove that MFD, and now we can just essentially fly off IMFD. Once we're 1,000 seconds away from this, we're going to do another adjustment of the eject time. Bring down to delta V. So we're actually just going to do the auto burn now. Auto burn and burn vector. We're 5,000 seconds away from our ISS encounter. Now we're going to tune our radios to the ISS's transponder frequency. The ISS's, we're going to program the ISS's transponder itself to the COM1 131.3, which is actually already programmed. So, okay. set that one to 131.3. The next one is going to be set to 137.4 for now, but we can change that to whatever frequency for whichever docking port we want. We'll put ourselves in docking MFD. Then leave it there. .800 kilometers away from the ISS in 2,000 seconds until closest approach. I'm going to do another orbital correction. Our course correction burn was IMFD.
Discovery Houston, we're watching the video and we see
That
no
course
deviation.
correction
We're
should be
wondering if this is
sufficient.
still picture.
Discovery Houston, Underground 2. Yeah, we actually playing that centerline camera view.
Yeah, we just wanted to pay tribute to the CDR because the target was so centered that it almost looked like this was a still picture. Great
We do
job.
one last auto burn right here.
Okay.
Now we're going to close that. We don't need IMFD for anything right now. Okay, we're going to open up two com navs, two docking MFDs. One running on nav 2 and the other running on nav 1. Now we're in the range of the
Translation. Rotation.
transponder of the docking port itself. Either 131.3 is a transponder for the ISS. So right now we have 220 meters a second of relative velocity. And I'm going to quickly bring up burn time MFD. Put the delta V at 220. How long will that take? 4 seconds, and it will take us 800 meters of distance to do that, so not that much. Very low relative velocity encounter, in other words. So what, 10 kilometers distance? At 20, actually. And you put ourselves in the retrograde direction from the ISS. Lights on. Whoa. Beacon, strobe. We're just gonna sit here and wait till we get closer.
5,000. 4,000.
This IMFD encounter basically puts us on a collision course with the ISS.
Translation. Rotation.
We can go into rotational mode. Put ourselves at the ISS. The rear of the ISS 3 kilometers in front of us. We just set our HUD to this frequency. There we go.
Translation.
Put ourselves in translation mode. I'm going to use this as an opportunity to turn on our APU. Open up the nose cone and retro doors in case we need them.
Rotation. In Information. Translation. APU fuel 70%.
I'm just going to get closer to the ISS here.
2,000. 1,000.
1 kilometer.
900. 800. 700. Rotation 600.
We're going to apply some retro thrust to get ourselves slowed down.
Translation 500.
Just to keep ourselves aligned here. Now we're going to adjust our rotation here.
Translation rotation, translation. Rotation.
Right now our rotation is really off.
Translation.
It's not aligning itself very well in translation.
Rotation.
You can really feel the effect of the gravity gradient torque and stuff like that here.
Translation. Rotation. Translation.
Stuff like that, the gravity gradient torque is having a real effect. Switch to HUD into visual mode, and we're actually too far away for that mode.
Sounds good. And one little
Rotation.
last thing. We're still working on activating the IMV valve. We've had some commanding issues on the ground, but we're working on it, so just so you know, it's not quite complete.
Translation.
I think not being into proper orientation does not help.
Rotation. Translation. 200. Rotation.
Station, we copy? Give us a second, we'll look at it.
And docking like this is really difficult.
Translation.
I'm not touching anything, applying any input, but it's drifting in rotation and translation. It's very annoying.
Rotation. Translation. Rotation. Translation.
Just touching the rotation mess
100.
translation messes the rotation and vice versa. And then yeah, stuff like that. Why is it going up still? Look, now my rotation's off again from just messing with the translation.
Rotation. 75.
Stand by.
Now that I adjust my rotation, the translation is completely off.
Translation. Rotation.
At this point, what I'm going to do is I'm going to use the attitude RCS into docking mode.
That's
Translation.
one way to do it.
So we're going to adjust
We
this
think it should
purely
take
in
about 20
translation.
minutes, and most of the time would be
And things were
devoted
inverted for some
to
reason.
locating the cables, and we
40.
can help with that.
And with the precise autopilot like this, holding our rotation, it's easy to dock. But unfortunately, it's just way too sensitive. While I'm here trying to get this MFD to work.
20.
Okay, and they still not.
And I just managed to crash orbiter somehow. Fortunately, I can just load the last save.
Welcome aboard, Commander. All systems nominal.
And our XR-2 is on the ground in the last... What? The XR-2 is on the ground in this mission. Alright, well I guess... Orbiter bugs. Guess I will probably end this orbiter stream. I'll probably to the later date to do this, but hopefully less, more bug free.